Hello all of you, welcome back to this channel. Today we are going to discuss about the ladder friction. So ये ladder friction क्या है आज हम इसी वीडियो पे देखेंगे. चलिए शुरू करते हैं. तो हम पहले देखेंगे this is the floor and this is the wall. Okay. Here we will be take this is the floor, this side is the floor and this is the rock wall. Okay. So here what happened? We can say a ladder is just resting upon the wall, okay, rock wall. So this is nothing but a ladder. Okay, so here what are the friction forces are appear, we are going to discuss. Okay, so we know that a body, suppose this is a body, the body is resting on the surface. That means there will be a weight force. The weight force is considered at the center of the body, so this is known as W. Okay, here also a ladder is there. That means the weight force of the ladder will be considered at the center point. That means this is the weight force of the ladder is known as W. Okay, next here we will be take this point as A and this point as a B. Okay, so if there is a body, we know that there are reaction forces are acting on it. So we can say a reaction force will be act in this direction is known as a normal reaction force. As it is, here also the contact surface is there from point A and from point B, RA, and in this point we can take the RB. Okay, तो नेक्स्ट हम देखेंगे यहाँ पर जो लाडर है वो स्लाइड होगा. तो जब लाडर स्लाइड होगा तो इसी डायरेक्शन में वो स्लाइड होगा. दैट मीन्स द मोशन ऑफ द लाडर विल बी लाइक दैट. सो हियर द रॉक वॉल इज देयर. सो हियर यहाँ पर जो हम देखेंगे जो लाडर है वो इसी डायरेक्शन में डाउनवर्ड स्लाइड होगा. ओके, तो यहाँ पर हम देखेंगे जो मोशन होगा लाडर का तो डाउनवर्ड्स आएगा एक मोशन. ओके, यहाँ पर भी जो मोशन आएगा वो स्लाइडर जो जो लाडर यहाँ पर जो स्लाइड होगा दैट मीन्स मोशन इसी डायरेक्शन में आएगा. ओके, एंड हियर वी नो दैट इफ देयर इज ए मोशन इन दिस डायरेक्शन, okay, ladder is slipping in this direction, that means there will be a friction force will be appear in this direction. That means we can say the friction force will be appear the opposite direction of the motion force. So this is nothing but the motion force. Okay, while the ladder is tends to slide. Okay, so we can say the friction force will be appear at the opposite side of the what motion force, or we can say the applied force. We know that if a body is there, we are pulling this body at a force P, then a friction force will be appear the opposite side of the applied force. Okay, so here we can easily understand if a motion force is there in this direction, then a opposite force is appear. So that opposite force is known as, or the resisting force is known as the friction force. So this friction force we can say the friction force at the wall. Okay, this is the rock wall. So here we will write the wall. That means F wall. Friction force at wall. Similarly, here the ladder will be slide in this direction. So the motion of the ladder in this way. So we can say the friction will be appear the opposite side. That means this is the friction force. You can see here. Here we will be write the friction force. Okay, will appear at the floor. Okay, that means in shortcut we will be write F. That means the friction force at the floor. Okay, this is the friction force at the floor. So here we get the two friction force at the floor at the what rock wall. That means F floor. Okay, So here we know that the formula for the friction force is what? The formula for the friction force is what? Mu into Rn. So at point A, a reaction force is known as Ra. Okay, so here we will be write the Ra. That means friction force at the floor is mu into Ra. Similarly, friction force at rough wall. Okay, so it is also mu into Rb. The reaction force is Rb. Okay, so this is the friction force will be appear while a ladder is resting on a rough wall. Okay, so here another things what you can see here, the length of the ladder we will be take here L. Okay, so length is this to this distance is L. That means the weight force will be appear at the center of the ladder. Okay, so here we will be take the distance from point A to center point is L by 2. Similarly, this distance will be also capital L by 2. Okay, so here the ladder friction we can say the two friction forces are appearing. Okay, a friction force here the flow of the floor and a friction force will be appear at the rough wall. So for the rough wall we can take the friction force as mu into Rb. You can see here. Okay, so mu is the coefficient of friction and Rb is the what? Normal reaction at point B. Similarly, at the floor, we can take the normal reaction as Ra. Okay, mu is the coefficient of friction. So these two things are very important while we are studying the ladder friction. When the wall is rough wall, then we can say the friction force are like that. Okay, so there will be a question will be appear if the wall is smooth, then what happen? If the rough wall is replaced with the smooth wall, then we can say there will be no friction at the smooth wall. That means what? The friction at the wall will be what? 0. Okay, so you will be right, if the wall will be smooth, then friction at wall will be 0. Okay, and the friction at floor will be as it is. Okay, but here if the wall is smooth, then we can take the friction will be 0. So that's all about the ladder friction. Hope you understand. So thank you all of you. See you in the next video.